when we are talking about a unit circle, it is a very specific circle. It's not just any circle that we might see. So when we are talking about it, the unit circle is a circle centered at 0, 0. We're going to see if this will ever focus. So quit zooming. With a radius of 1. So if you think about like graphing anything that you did back in Algebra 1 or whatever, you know where 0, 0 is. If you go 1 in every direction, that's your radius. That's our unit circle. Now, to start, I actually want to go to the back of this. So actually fold your paper in half first. So you've got a little book. And we are going to look at the back page first. So talking about special right triangles. So these are the special angles we've looked at. So first, let's say I have a 30, 60, 90 triangle. Okay, we have, we did this in our notes back in, I don't know, in the last chapter, where we looked at if we had an equilateral triangle. So equilateral, all these angles would be 60, right? And if we dropped a perpendicular, that makes a right triangle. And we said, okay, if the original triangle, every side was 2. Then if we take just this right triangle, this side is 2, this would be half of 2, which is 1. And then we could do Pythagorean theorem to get the other side. A squared plus b squared equals c squared. Do you guys remember doing this in our notes? So your other side turns out to be the square root of 3. So in this, the hypotenuse was 2. We had one side of 1 and one that is the square root of 3. And so that's from our notes, what we did at the beginning. So in this, my angle measures were 30, 60, and 90. And then those were our sides. Okay, the second special triangle is a 45, 45, 90 triangle. And we did one of those in our notes back then. If these angles were the same, these sides are the same. So if both of those are 1, what would you get for this other side? 1 squared plus 1 squared. So our angles were 45, 45, and 90, and our sides were 1, 1, square root of 2. All right. Those are really all that we need. So I'm going to stop there for a second. Those were the two that we've talked about so far. Okay. So let's go. You have this page with a bunch of triangles on it. So we are going to cut those out and we are going to label them with some of our information. Okay, so this first one, we have glued our triangles so that these are all 30-degree angles coming out from the center. Okay, because we have our 30, 60, 90 triangles. These are the right angles over here. Now, from what we just talked about with our angle relationships, when we had the 30-degree, 30, 60, 90 triangle, the side across from the 30-degree had a length of 1. So if I come across from my 30, this side has a length of 1. Okay? However, the problem with that is, then what would my hypotenuse be? It was 2 from here. But on a unit circle, what's the hypotenuse? 1, because the radius is 1. So what we're going to do is divide each of these numbers by 2 to create a triangle that has a hypotenuse of 1 to match the radius of our circle. So that means this side is going to turn into a 1/2. Okay, these are my hypotenuse, or the radius of the circle, that's 1. And then this side would be square root of 3 over 2. So if we think about this as just a graph, if we're plotting points, okay, if I come out here, this is the point 1, 0. If I go up, an ordered pair is x, y. So my x value was radical 3 over 2, bless you, and my y value is 1/2. Now, when I go this way, if this were centered at 0, 0, what would be true about my radical 3 over 2? It would be a negative because you went left. And when we go down, that's negative. Okay, so some of these would have a negative. So if I go this way, and I look at this point on my circle, then my x value is negative radical 3 over 2, and my y is positive 1/2. Okay, when I come down here, negative radical 3 over 2, negative 1/2. And over here,
Positive radical 3/2, negative 1/2.
okay. And those numbers aren't just made up, those are actual measurements. If we were dealing with the perfect circle with a radius of 1, and we were looking at those lengths, that would be the actual coordinates on my circle. Are we okay with that? So we're going to do the same thing.
On the next one, the same kind of triangle.
So now we're doing the 45 angle. So that should be the one that's isosceles, the triangle that's isosceles. And your 45-degree angle is coming out from the center. Okay, so your next, these are how we are gluing the next two.
You have a problem with your tape?
It is very skinny.
Your Honor, you weren't even there.
I just said that.
Oh, I didn't hear you.
No, I never touched it. Okay, see. Okay, after the lunch.
So if we're talking about our 45s, okay, the right triangle we talked about, the sides were 1, 1, square root of 2. Okay, but if we are going to put this on a unit circle, the unit circle has a radius of 1. What the radius is your hypotenuse. What would we have to divide that by? Square root of 2. So if we divide that by the square root of 2, we would get 1. 1 divided by the square root of 2 would turn into radical 2 over 2. So both of those are the radical 2 over 2. Okay, so I took the special triangle we had, we divided it so the hypotenuse was 1. So now if we look at it, this is 1. These would both be radical 2 over 2. But if you're going to the left, that is negative. Up is positive. Down is negative. So if I want these 4 points as I'm moving about my circle, this ordered pair the x is radical 2 over 2, and the y is radical 2 over 2. Okay, if I go this way, my x is negative radical 2 over 2, and my y is positive. If I come down here, they're both negative. And if I go this way, we have positive and negative. So all of these ordered pairs, they are based off what the actual points on this circle would be if my angle were 45 degrees. Do you guys understand where we're getting those? So the final one we have to look at is when the central angle is 60 degrees. Okay, and that is the same triangle as my 30, 60, 90, but the sides are flipped. So my radius is 1. So if you look back, the side across from 60 degrees was the radical 3 over 2.
I didn't even write my degrees.
And the side opposite the 30 was a 1/2. So my points, x went over 1/2, y went up radical 3 over 2. So this x, we went back 1/2, and we went up radical 3 over 2. Okay, we went down.
Do we put our sides and stuff in on the top?
Hmm.
On the special right?
You don't have to. It's up to you.
I will put it.
Okay. When you finish filling this out, I want you to get out the big unit circle we had the other day.
I have to.
All right. The unit circle that you guys already have, we have part of it filled in, right? We had all of our degree measures. So 0, 30, 45, 60, 90. And then we jumped down here. This was our 180. And how did we get the other angles?
You do your reference angle.
So 180 minus 30, 180 minus 45, 180 minus 60. In this quadrant, what did we do?
Added 90.
So 180 plus 30, 180 plus 45, 180 plus 60. This was our 270. And we know 0 is the same as 360. So 360 minus 30, minus 45, and minus 60. Okay, so that's our circle. Now, we did radians, and we did that at first by multiplying by pi over 180. So 0 times pi over 180 is 0. 30 times pi over 180 is pi over 6. Pi over 4, pi over 3, pi over 2. Does everybody know where I'm getting those? Okay, we know 180 is pi. And I told you that with the reference angle, so everything with a reference angle of 30 will have what in the denominator? Yeah. Oh, my pen is dying. That's sad. Okay, that did not work at all because my pen wouldn't write. So the denominator should be 6. And over here we said, well, the pattern is it's 1 less. Down here it's bigger than pi, so it's 1 more. What was the pattern over here?
Double minus 1.
Mm-hmm. So 6 times 2 minus 1. All right, and then as we go out, all of these with a 45 have what in the denominator? Okay, so in the second quadrant, the top is 1 less, so 3 pi over 4. Then 1 more, so 5 pi over 4. Double minus 1, so 7 pi over 4. Okay, then everything with a reference angle of 60 has a denominator of 3. So 1 less would be 2 pi over 3. 1 more, 4 pi over 3. Double minus 1, so 6 minus 1 is 5 pi over 3. Next, we are going to add ordered pairs to this. Now, this is a unit circle, so this is like 0, 0 right here. And my radius is 1. So what is this ordered pair? 1, 0. What is this ordered pair?
1, 1.
0, 1.
Oh, yeah.
What would be this ordered pair?
Negative 1, 0.
And this one. Okay. Now, let's talk. When my reference angle was 30. Okay, whoops, I labeled one of those wrong. So when my reference angle was 30, look at your picture that we just got done doing. What were my points?
Yeah, 33 over 2 and 1.
So the x was radical 3 over 2. The y was 1/2. And it was the same on all 4 of those. The only thing that changed was negatives, right? So if you're in the second quadrant, your x is negative. Your y is positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, x is positive, but y is negative. Okay, so those are the 4 points from my 30-degree picture. My 45. What are my points? Okay, so all 4 of these are the same, except in the second quadrant, the x is negative. In the third quadrant, both x and y are negative.
May I have everyone's attention, please? The following is just a drill. I repeat, the following is just a...
Radical 3 over 2. Okay, in the second quadrant, the x would be negative. Third quadrant, they're both negative. Fourth quadrant, x is positive, y is negative.
Negative radical 3.
Okay. So now, here's something that I want you to think about. Let's go back to our hand trick. Okay. At 0 degrees, what is the sine of 0? 0. What is the cosine of 0? At 30 degrees, what is the sine of 30 degrees? 1/2. What is the cosine of 30 degrees? Radical 3 over 2. At 45, what is the sine of 45 degrees? And the cosine?
32 over 2.
At 60, sine is?
1/2. Oh, yeah, sorry, yeah.
And cosine?
1/2.
At 90, sine is? And cosine is? Because remember, the definitions sine is y over r. But in a unit circle, your radius is 1, so your sine value is the y. The definition of cosine is x over r. But in a unit circle, your x is 1, so cosine is the x. And these other quadrants have to do with the all students take calculus when things are positive or negative. So on this unit circle, x is cosine and y is sine. Tangent, remember the definition of tangent
It's just
was
the two
y
divided.
over x,
It's just the two divided.
so you divide them. So if I said the tangent of 3 pi over 4, it's radical 2 over 2 divided by negative radical 2 over 2. So you get negative 1.
I feel like
So if you know your circle, if you can fill it out, I could look at it. If I said, what is the sine of 315 degrees? Okay, 315, sine is negative radical 2 over 2. If I said, what is cosine of 7 pi over 6? 7 pi over 6, cosine is the x. It's negative radical 3 over 2.
sine is one.
Yeah. And if you want secant or cosecant, what do you have to do?
Just flip it.
Flip them. Okay.
That's so dope.
So we are going to work with this a lot more. We don't have a ton of time left today, but you actually already have enough to do a lot of your homework. I'm going to go ahead and give it to you. We will finish Monday, so we're not done with the section, but a lot of this homework is just what is the sine of 5 pi over 3? What is cosine of 7 pi over 6? So things that we have already been doing. I still strongly encourage you to do your quadrants and reference angles to practice that skill. But this circle can also help you.
So, what's supposed to, are we supposed to be using this circle?
So I would say, okay, what quadrant is 7 pi over 4 in? Quadrant 4. Reference angle is pi over 4, or you can say 45 degrees.
And
So
then cosine of 45.
cosine in quadrant 4 is cosine positive or negative?
Negative positive.
Positive. Cosine of 45, we're going to 2 over 2.
Oh, quadrant 4.
And
I thought you said quadrant 2.
quadrant 4 is sine positive or negative?
Negative.
Negative. What is the sine of 45? And then if you look on your unit circle, you should have that point.
Dope.